entire process that begins here and extends to the special summit at the UN General Assembly in September, continues through next March when nations will speak and express their ambitions and outline their commitments, and then, of course, in Paris in December of 2015. And to John Ash, I would say, you mentioned the process that has gone on thus far. There was a famous poet in my country, long since deceased, Wallace Stevens, who once wrote the lines, "After the last no comes a yes. And on that yes, the future of the world depends." There were many no's that confronted those who have sought to address every significant challenge in our world. And after all the no's, there will be a yes. I bring you good news here today. Actions are already being taken. The business community is moving swiftly. The investor community is moving. Many regional and local governments are moving. Some national governments are moving. We are going to prevail. The only question is, how long will it take to prevail? The working sessions here are extremely valuable, and I would like to say to the ministers who have come here, it's extremely important that the work be productive here in all of these sessions. Energy efficiency, lighting, motors, alternative energy, sustainable agriculture, sustainable forestry, acting on the short-lived pollutants where we can have action, finance, where I will be spending a lot of my time over the next 2 days. But I want to address two questions in these opening remarks. There are really only two questions the world has to answer in order to solve the climate crisis. The first is, do we really have to do this? We've had 150 years of carbon-based energy. It's been a long, good run. Do we really have to do this? And the answer is very obviously yes. And I'm going to show you some pictures that illustrate why that answer is yes. But the second question is even more important. The second question is, can we do this? When we decide to really face this challenge, can we solve it? And I have good news to share with you on that question. Private investment, by the way, for all the talk about aid flows that have paralyzed such progress for so long, the private investment flows that are being unlocked as we begin to make this low-carbon transition are 1,000 times greater than all of the government funds that anyone has ever discussed. So let me show you a few pictures. So first of all, we just entered the month of May. Last month, April, was the first month not only in human history, but for millions of years, that the level of CO2 in the atmosphere was above 400 parts per million. Last year was the first time it ever exceeded that level. Last month was the first time it exceeded that level for an entire month. This, of course, is the subject of discussion today. This is why the Earth system is vulnerable to the gaseous pollution that we are putting into the atmosphere. This is so thin. We are using this as an open sewer. We are dumping 90 million tons of heat-trapping pollution into it every 24 hours. And we have to stop doing that. The sources of all this global warming pollution will be discussed in the working sessions. Of course, we'll be hearing a lot about the burning of carbon-based fuels, but it's also industrial agriculture and factory farming and transportation and inefficient buildings and cities that are poorly designed and the burning of forests. But the main part of the problem, and the one that we must address in order to find solutions for all the rest, is the fact that 85% of all the energy we use on Earth is coming from carbon-based fuel. We didn't realize we were going to cause this problem when we started tapping this energy, but we did. So as CO2 increases, so does the temperature. 2,000 years of CO2, 2,000 years of temperature. This is well understood. And as a result, we have seen a steady buildup of heat in the Earth's atmosphere and in the Earth's oceans. And in the last several decades, the process has accelerated quite dramatically. And I will show you that in just a moment. But starting in the 90s and then in the 2000s, we have seen the buildup of heat. 13 of the 14 hottest years ever measured have been in this century. And it's 2014. These are the 12 hottest years on record. Last year was the 37th year in a row warmer than the 20th century average. Last month was the 350th month in a row warmer than the 20th century average. Now this may look complicated, but it is really not that complicated. I'm not good at statistics, but it's fairly simple. The scientists have measured the temperature of the entire Earth in small blocks. And they took the 30 years that began the second half of the 20th century, 1951 to 1980, and said, let's make that normal and see what's happened. And as you see, the white represents normal days, normal temperature. Blue is cooler than normal. Red is warmer than normal. In the 1980s, everything shifted toward warmer than normal. And all of a sudden, we get these extremely hot days on the lower right. In the 1990s, it continued to shift. We still get cold days, but the average is shifting quite dramatically. And in the last decade, the warmer than average days are dominant. And all of a sudden, the extremely hot days on the lower right are more numerous than cooler than average days. In fact, these extreme heat events are now 100 times more common than they were just 30 years ago. And that is what is causing the disruption of the water cycle and the extreme weather events. Most of the energy is trapped in the oceans and atmosphere. But if you look at all of it together, the cumulative amount of man-made global warming pollution is now trapping as much extra heat energy every day as would be released by 400,000 Hiroshima atomic bombs being exploded every 24 hours. It is a big planet to live on, but that is a lot of energy, 400,000 times every single day. The ocean absorbs the vast majority of it, and so ocean-based storms are stronger. Super Typhoon Haiyan, when it came across the Pacific Ocean headed toward the Philippines, crossed a section of the Pacific that was 3 degrees Celsius warmer than normal. What was the result? Well, you know, the strongest typhoon ever to hit land. The devastation was heart-wrenching. And this morning, as we meet here, there are still 4.1 million homeless refugees in the Philippines. We talk about adaptation, and we do have to adapt. Resilience, and we do have to find resilience. There are many countries that are not able to recover so easily from these events that we are making so much more destructive and so much more common. In my country, John Ash referred to Super Hurricane Sandy. The Atlantic Ocean, just to the windward of Manhattan and New Jersey, was 5 degrees centigrade warmer than normal when Hurricane Sandy hit. And of course, the results are well known. Even the ground zero site.
The Hudson River, downtown Manhattan, was literally pouring into the ground zero.
People said that could not happen. But it did happen. And the land-based storms are also much stronger. Why? Because the warmer oceans not only drive stronger storms, as the temperature of the oceans increases, much more water vapor is put into the sky. And the warmer air holds more water vapor.